The four main features that were introduced in Tecplot 360 2017 R3 are PyTecplot recording and connections. PyTecplot is our Python API that was released for the first time in January. We've also added a VTK loader, the VTU format to be precise, and we'll talk about that more. Also LaTeX fonts. We'll talk about how to use LaTeX to make your presentations and your report quality plots more engaging. And then we've made numerous enhancements to slices and isosurfaces to try to make your job easier and extract useful information from your data sets. Okay, so let's start with PyTecplot. For those of you that have not used or seen PyTecplot before, let's start out with what it is. PyTecplot is our Python API. It is a Python module that uses your installation of Python. So if you have Python 2.7 installed, Python 3.4, 3.5, or 3.6, you'll be able to use this module. It is a separate install from Tecplot 360, but does depend on Tecplot 360 being installed. So in order to use this, first make sure that you install Tecplot 360, and then you can use the pip command, which is Python's package manager, pip install PyTecplot. And that's really all there is to it. The installation is hosted on Python's PyPy servers, so if you have an internet connection, it's very easy to install. If you don't have an internet connection, the Python package is included in the Tecplot 360 distribution. And you'll be able to find all of that information right in Tecplot 360. We have, as you can see here in this screenshot, we do have very good documentation for our PyTecplot Python API. Now, a note, this use of PyTecplot does require that you have an active Tech Plus support subscription with us. So make sure that you're up to date on your support, and you'll be able to get all the advantages of Python. So new for this release is the ability to record Python directly from the Tecplot 360 user interface and then play those scripts back to control a live running Tecplot 360. In the Tecplot 360 2017 release 1 back in January, we only had batch mode available, which is useful, but this really now provides a step function, we believe, in the way that you can control Tecplot 360 from Python. So to record Python macros, it's just like recording macros, or sorry, to record Python scripts, it's just like recording Tecplot macros. You just go to the scripting menu and you can say record PyTecplot, and then any action you take in the user interface will get recorded into a script. Really what this does is it really helps you get started quickly with a new and very unfamiliar API. Many of you haven't seen this yet, and so you don't have to wade through the documentation to learn the API. You can just record scripts and get an idea of what the API looks like. So in this little code sample here, I've recorded a script that simply turns on the mesh and changes the mesh color to blue, and then finally exports an image. So you can see how relatively simple and expressive this, this API is, and how quickly you can get started with it. Now, our documentation does have a lot of examples, and we have a lot of screenshots, so you can really get started quickly by looking at the documentation as well. Now, you'll notice one line in this little script here that's commented out. It says tp.session.connect, and we'll talk about that on the next slide. So in order to play your Python scripts back, it's a little bit different than playing back a Tecplot macro. You're not going to execute a Python script directly from within the Tecplot 360 user interface. You're actually going to execute your Python script separately, and it's going to communicate with Tecplot 360. So in order to enable that communication, you go to the scripting menu and you select PyTecplot Connections, and then you make sure to toggle on accept connections, as you can see in this dialog on the lower right of the screen. Behind the scenes, we're using a sockets connection to do the communication, and what this allows us to do is have a Python script that can be completely separated from Tecplot 360, but then communicate through this protocol. Tecplot.session.connect is really the only additional line of code that you have to add to your Python scripts to get it to communicate with a live running 360. If you don't have that function called, then we're going to essentially run in a batch mode configuration. So this is now going to allow you to do some really interesting things with the Python language. You can even use Python GUI toolkits like PyQt to create simple dialogues to control Tecplot 360 to streamline your workflows. We have a number of users who are already taking advantage of this capability, and hope that you'll give it a try, and of course let us know if you need any help, and if you want to streamline workflows. Our support staff are here to help, and Python is a great language for doing that. So now, why would you want to use Python instead of Tecplot macros? You know, the Tecplot macro language has been around for a long time and is really quite useful. But where Python really wins out is it's a real programming language. So you have access to better flow control methods like for loops, while loops, if statements, else if, that sort of thing. You have real string processing. You have array handling, and the array handling is one thing that's really important that you can combine with PyTecplot's ability to actually access the raw data. So PyTecplot is more than just a toolkit for setting up your plot style and creating an image. PyTecplot is a tool that allows you to do additional data analysis. You can extract information from your plots. For instance, we have a user that we were recently working with who is trying to compare wind tunnel results with simulation results, and he's able to use PyTecplot to programmatically extract information at pressure tap locations and compare that with the wind tunnel results. So it really helps with the automation and extracting that information with the Tecplot macro language. The macro language is really just not designed to do that data extraction that you can do with Python. So PyTecplot can do anything that a Tecplot macro can do and more, as we were talking about with the data extraction. The other advantage is PyTecplot can be embedded in your Python script. So if you're already using Python to automate workflows, you can now use the power of Tecplot 360 within those Python scripts. And for other resources, I'm not going to give a demo of PyTecplot today. We had a webinar a few weeks ago that is available on our webinars page, which goes through a really extensive demo of how one can take advantage of PyTecplot. That's available at tecplot.com/webinars. In that webinar, we show an example of how to do sophisticated data analysis, as well as demonstrate a simple user interface that we were able to create using the PyQt toolkit. You can get more information on PyTecplot also at our website, www.tecplot.com/PyTecplot. And there you'll find documentation, installation instructions, video tutorials, and FAQs. A lot of that information is also available right within the Tecplot 360 user interface. So if you have any questions, again, don't be shy. Go ahead and tap them out, and I'll be happy to answer them. Okay, let's move on to the next major capability that we've added to Tecplot 360 in this latest release is a VTK loader. Now, you have to know that VTK has a lot of different file formats, and this latest release, we're supporting one of them, which is the VTU file format. You see a couple other file extensions here listed, VTM and PVTU, and those file types are effectively just wrappers to a VTU file. So a VTU file, each VTU file effectively represents one zone in Tecplot 360. So in this wrench example here on the left, you may have two VTU files, one representing the wrench itself and one representing the bolt that it's attached to. A VTM file is a single file that references multiple VTU files to bring to be able to load multiple zones simultaneously, and then a PVTU file is a parallel VTU file. So if you have a code that is running distributed on an HPC, they may write out a portion of a zone on each rank of that HPC. And then a PVTU file is going to give instruction for how to stitch all of those pieces of a zone back together to create a single zone. And this is really exciting because this effectively makes us compatible with a few new solvers, COMSOL being one of them. COMSOL has an option to write out VTU files. We've worked with the developers of COMSOL to make sure that we're compatible with the VTU files that they export. SimVascular, this is a code out of Stanford, and we've also worked with them. Envenio is a meshless CFD code that really works well on GPUs. That's their one of their claims to fame. And PyFR is a research code that focuses on higher order elements, and this makes us compatible with all 4 of those codes. So we did have a question come in ahead of the webinar, which was ParaView files like VTU take a lot of time to load. How do you optimize loading of these file types? Well, this is really interesting. You have to know which type of VTU file you have. VTU comes in 3 different flavors. ASCII, which is going to be slow. ASCII files are inherently bigger on disk, and the more data on disk, the longer it takes to read those files. They also have what they call a binary format and a binary appended, and the difference between these is really important for the speed in which that data will come into Tecplot. So a binary file is better because you get the compression of the binary format, but there is header information distributed throughout the entire file, and Tecplot has to scan through the entire file to understand what variables are embedded within that file. So this user I contacted prior to the webinar, and it turns out his data file is about 20 gigabytes in size. And in order for Tecplot to understand all of the zones, or sorry, all of the variables that are in that data file, we have to scan through all 20 gigabytes of that data file. And we can try to skip through the data section, but still we have to get to all of those header locations. So binary is better, but it's still going to be quite slow. Binary appended is the best, and the reason being is all of the header information that Tecplot needs to understand what's in that data file is right up at the very top. So we have to read very little data, and we can, and then we can load that file. And only when you actually need data, say you're going to show, von Mises stress here, is when we actually load that data. So you're going to get very fast load times with that. So if you have control over the output, prefer writing out binary appended. If you don't have control over the type of VTU file that's written, you can always convert to a Tecplot binary format, which is going to give you very good performance. The Tecplot sizzle format, this is our subzone load on demand format, is going to give you the best performance. And this is compatible with the VTU data. We do have some tutorials on our website for how to convert data to the sizzle format, and this is going to really reduce the amount of memory used and give you very fast load times, orders of magnitude faster with this new file format. And again, on our website we do have some quick tutorials on how to use the VTK data loader. Okay, moving on to LaTeX fonts. Now this feels like it's been a long time coming, and we're happy to be able to provide this capability to our users. So first off, what is LaTeX for those of you that don't know? LaTeX is a high quality typesetting system designed for technical and scientific documentation. And one of the things that Tecplot has been known for many years is report quality plotting and presentation quality plotting, and this really helps cement, I feel, cement our reputation in being able to create report quality plots. By being able to put complex formulae right on your plot, you're going to be able to communicate better with your end users. So the way this works is we didn't build a LaTeX parser right into Tecplot 360. We're actually relying on your version of LaTeX. So if you don't have LaTeX installed on your machine yet, you'll have to do that as a prerequisite to use this capability. We've tested with two major LaTeX packages, one called MikTeX and another one called TecLive. So make sure you install those first, and the default configuration for Tecplot 360 should work very well with both of those packages. And we do have a configuration file to allow you to customize that configuration. That is in the Tecplot 360 install directory. It's called tecplot_latex.mcr, and we have examples in our documentation for how you can modify that. LaTeX has a number of different packages for rendering different fonts. We don't have all of the packages marked for use by default, so if you have some special symbols or some special libraries that you need to use, you may have to add those in that file, so be aware that that's there. And the place where you enter the LaTeX syntax is in the text details dialog. So if you're familiar with adding text to a plot, you do it just the same, and there's a LaTeX button right in the text details dialog that allows you to enter the text. So how do you actually format text? Well, number one, I'd recommend clicking help on the text details dialog. We've added a number of examples in there to give you a bit of a quick start on what the LaTeX syntax looks like and some ideas of what you can type into the fields. So here are some examples. Some of these come directly out of the Tecplot 360 user's manual and online help that you can get to when you click help in the text details. You can see Greek characters much easier to enter now once you have LaTeX. Greek characters are one of the questions that we get quite frequently, and I'm really happy that we're going to be able to provide very high quality Greek characters through the use of LaTeX. And you can see some of the more interesting typesetting that you can do with LaTeX in that bottom example. You can have multicolored text, multi-size text. You can include text boxes as well. So some interesting examples for making your images and your presentations a bit more visually arresting and easier to communicate. And again, we do have examples on our website and a couple of videos that you can see through that link there. Okay, the final main feature that we've added are a number of enhancements to slices and isosurfaces. The first thing we've done is made it easier to place and extract slices without ever displaying them. And the reason why this is important is because once you display a slice, Tecplot actually has to go through the work of loading the data to create that slice and to show the, say, the contouring variable that you've applied to that slice. So if you have really large data sets, hundreds of millions of cells, it can take a few extra seconds to get that slice to render. So by a couple small changes we've made to the user interface, you're now able to set up the placement of that slice and extract it before ever actually displaying it, speeding up workflows. The next thing we've added is this new extract slice dialog that you see on the screen here. It allows you to extract slices from a specific slice group. Tecplot allows you to set up to 8 different slice groups, and previously you had to extract all of the slice groups simultaneously. So if you're using more than one group, this can help you with extracting just a single group at a time. Then we've this central option. It says create a zone for each slice or connected region. And so the example there is, if you look at that image down at the bottom, we have a manifold with 4 exhaust ports. Let's say I wanted to calculate mass flow rate through each one of those individually. This is a situation where I would want to isolate each one of those separate regions. So I would select create a slice from each connected region, and in that case, when I do the extraction, I would get 4 individual zones that I could then do the mass flow integration on. Another situation would be, say you have an aircraft and you're doing a surface slice, and your slice happens to pass through both the wing and the tail of the aircraft, and you want to have those as separate zones for doing integration using the connected region. You can isolate those regions. And then the final item for extracting is extracting to an I-ordered zone. Now this is important, again, if you're doing surface slices and you need to take that data out of Tecplot 360 and pass it to another downstream post-processing program, or if you're comparing with experimental data, you may need data that is in a nice ordered array. Previously, Tecplot would always extract to an FE line segment, which can be a little bit more difficult to use for downstream post-processing. And then the final one on isosurfaces, you can now display vectors on your isosurfaces. This has been available for slices for quite a while, and we're getting just added that capability to isosurfaces in this release. Okay, we're almost done here. So one of the other questions that came in, not necessarily related to R3 itself, but what free training is available? Well, we have quite a lot of training assets available now. We just launched a new page on our website, which is the Getting Started with Tecplot 360. You can see the link there. This has some nice resources if you're new to 360 and want to get a quick start. PDF guide, our documentation, we put a lot of work into that. We're trying to put out video tutorials. We're trying to get, one a month or one every other month to help out with tutorials. And if you have any questions or want to see a video on something, please reach out to us. We're happy to make videos when we can. And then free one-on-one training. This is available when you renew or upgrade your Tecplot license, and also when you download a free trial. If you're a new user to Tecplot 360, we're happy to give you some one-on-one training. Okay, and a couple of questions came in here, so let me tackle those before we move on to the next slide. I joined late, so yes, slides are going to be available. They'll be posted to our website in a couple of days, and this webinar is also being recorded, so you can see the whole thing later. And let me read this one. Is the new slice extraction feature available in PyTecplot? Yeah, the answer is yes. So any feature that goes into Tecplot 360 is going to be available to the Python layer as well. So, the PyTecplot does get updated along with Tecplot 360. So, as long as you have Tecplot 360 Release 3 and install the latest PyTecplot, you should have that capability. Okay. So if I'll hang out here for just a couple more minutes to take some more questions, but if there are no other questions, we'll go ahead and adjourn. So thank you for joining. This will be posted on our website. We are going to be at the AIAA SciTech Forum in January. Please stop by our booth. I won't be there, but we will have a good contingent of Tecplot employees, including our president, Tom Chan, our director of sales, Alan Klug, and our CTO, one of our developers. So it's going to be a good contingent, and if you have any questions, they'll be able to help you out there. We'll also have a reception while we're at the conference. And if you ever have any questions, please do contact our support staff, support@tecplot.com. They're available here 6:30 a.m. to 5 p.m. Pacific time. And if you are in a different region of the world outside the US or Canada, please, you can use your local distributor for support in your time zone. Okay, thank you very much. It looks like there are no other questions, so I appreciate your time and attention, and contact us if you have any questions. Thank you.